It's supposed to be sandwich. I mean sandwich. I just say sandwich. So sandwich. Yeah. Okay, so we got ham. Oh, mayo. I also like mayo too. My sister hates mayo. She likes to put sour cream on it instead. Kind of like a torta. We got fresh mozzarella, and then just bologna for me. Bologna, and then some more bacon fans. Ooh, wow, Doritos inside. That's interesting. And we got turkey. Okay. Doritos. Well, I remember back when we were in session, like last year, people would bring, like, students would have these bagels with hot chips inside. Like, I've seen you all eating that. So that is like, I don't know if y'all like that, but I've seen that and I was very interested. Or some people put Takis with a bagel and cream cheese in a bagel and then they eat it. So that was interesting. So yeah, I have never had a sandwich with Doritos in it, but then after a swim, okay. So that must be a good thing to try. That gets me interested now, actually. Welcome to those that just came in. We are answering this check-in question on what is something a good sandwich has to have. Hopefully y'all ate lunch 'cause I don't want to make you guys hungry. But yeah, I eat later, but this is making me hungry now. All right, let's see. Then we have some some arguments about the Doritos and the sandwich. I think I'm gonna try that, to be honest. That sounds really good actually. All right, let's see who we're missing. Let's see. And I just sorry again, I got too into the check-in, but let's see. I am missing Ariana. I am missing, hold on one second. Make sure market. I am missing Ariana, Dennis, Miles, Kayla, Alicia, August, Marco, and that's it. Again, I apologize. Let me just double check this. Hold on, hold on. Yeah, that's who I'm missing. So once more, one more round. I am missing Ariana, Dennis, Kayla, Alicia, and Marco. So if you are friends with any of these folks, if you could, get them to come into math class. We have round two of some participation credit. We had some yesterday as well. I think I did put it in Power School for y'all to check and whatnot. But definitely, if you do need to make up anything, just let me know. Send me an email. I'm happy to put in your credit. Okay, no problem. Thank you. Yeah, I am recording today's lesson, so definitely. I can't. Wait, so Lolly, do you really like seaweed? I actually like the snack seaweed, like where you snack and they're salty. If so, that's cool. I never had it in a sandwich. Okay, seaweed. Oh, never mind then. So Lolly says no. Never mind. But we have a lover of seaweed. I actually did not get into it until another teacher was like, You want to try some?" And I was kind of creeped out, but I tried it and it's actually pretty good. Lower calories too, so less oily, I think. All right. Thank you so much for your sharing on that check-in question. If you just came in, if you could send me a direct message so I could correct the attendance. But welcome. Let's go ahead and check out what we're doing here today. Our agenda. So I just took attendance with that fun check-in question. Um, and then oh my gosh, allergic to avocado. I'm sorry. This is, I'm getting too into this question. Allergic to avocado? If so, dang. Or you mean seaweed? Because I've heard sea ones allergic to like seafood. And yes, I agree, Tyree. Avocado is a must. All right. Sorry, let me just correct the attendance here. There we go. Okay. Awesome. Okay, so I just took attendance with the check-in question. And now we're going to jump into discussing more deeply about waves and their properties. There's going to be one Padlet question and then one Google form, and that's today's credit. So Padlet, Google form. Just make sure you try them both. Again, remember, it's not based on getting it wrong or right. It's more like you're sharing your thoughts. And so anyone who's sharing their thoughts here, you're going to get an A. You're going to get your credit for this. Then we're going to have our checkout and asynchronous number 12 this morning. I finally kind of tied up any loose ends and I finally posted it. So, asynchronous number 12 is actually part one of the mini final. This one, I would like a draft of this due and for you to at least read through part one by Wednesday. Definitely, because there's two parts to the mini final. The whole of it is posted already, so you could read through it. But basically, part one, you'll see once you open the document, it's going to be due Wednesday and it's totally doable. It's yeah. So hopefully we have time at the end of class so I could open it and show you. But if we don't, the instructions are on there. Let me know if anyone has questions though, before I move on from this agenda or about anything I just said. All right, awesome. So no questions. Let's go ahead and get started with today's stuff. Let's see. Okay, quick recap on, oh wait, actually, let's see if there's a question, my bad. Okay, awesome, awesome. All right, so quick recap about what we did yesterday. So yesterday we met up. We talked about the period of a function, and then we even had like a Google form yesterday, and then we came back together and kind of addressed a misconception about what a period was. But basically, any periodic functions are the ones that repeat over time, right? Any periodic function has a period called p, and usually it fits this definition. Like if you plug in your value and after certain p period, you're going to get the same y output. So for example, down here, this sine function repeats after every 2 pi. That means this same wave that's right here in green, like side to side right there, that length right there, every 2 pi, that same wave is repeating over time. That's what that means. So that is the period of this sine function. And it's, you can see it right here. I replaced that p right here with the 2 pi here. And for different functions, the period is going to be different. So some could be 2 pi, some could just be a pi, like it's more smaller. For some could be even longer, like more stretched out. Depends. So that is what we did the other day. And we also discussed like how to actually measure it, right? With a graph. This is the thing where we came back together and we discussed that Google form answer and this strategy where you are measuring the distance between two maximum points. And then you're using your x-axis as a ruler. So for this example, I measured the distance between these two maximums, but I don't know what the length of this red line is. So that is where my x-axis can help us. We can use the x-axis as a ruler. So I just took this same distance and I dropped it down here. And for this particular function, the period is 4 pi. That means every 4 pi, wave right here that you see, this wave happening repeats. So that's what it means when we're talking about period. So that was a little quick recap of what we did the other day. Let's see if anyone has any questions about this recap. All right, cool. And if any questions come up, just feel free to put it in the chat and I'm happy to go back. But that was what we talked about the other day. Let's go ahead and transition to today's topics. All right, everyone. So I am on slide, and it's hard to see, but I'm on slide number 5. We are day 8 here in pre-calculus. Trigonometric function properties. Learning target for today is I can transform. So transforming sine and cosine waves or other trigonomic functions to model situations. So I don't know if we're going to get to actually transforming sine and cosine functions, but we're going to just take a look at how to kind of create equations from a model and or a graph. So that's going to be more so our focus, but that's there for you as well, because transforming is something that you'll get to do in the mini final once you try to kind of create an equation to represent a sound, but we'll get to that once we do. But that is our intro for today. In order for us to actually transform, kind of what I mean by transform is like you're stretching a wave or you're compressing a wave or you're moving it up and down, you're changing a wave. That's what it means to transform it. In order for us to do that, we need to have certain properties down. And that's what we're going to talk about today. So let me just give you a sec to just read through the learning target and the title. Okay, let us begin. Let's see. So I am now on slide 6. To open us up here, I have for you a representation of a sine function with its parameters. That's what A, B, C, and D are called. They're called the parameters of a sine function. These parameters can help you create an equation for a function. But before we dig into it, we're going to start off with a notice and wonder on a Padlet. So that's participation, first point participation, 50%. The other half is a Google form. So let me go ahead and make sure everyone has a link. For those following along, the link is right here in the notes section, but it's the same Padlet. So let me just bring this up. Here we go. All right, I'm gonna stick this in and let's go ahead and have about a minute. Once I post it, don't worry, I'm gonna start it after. Once I post this, we'll have about a minute to go ahead and just put what we notice and wonder when it comes to a sine function and any connections you can make with these parameters and what you're looking here, what you're seeing in the graph representation. So let me go ahead and open up this Padlet. And it's loading for me. See number 9? I think so. I think it's yes. Yes, number 9, you are correct. That is where we're at. We are on this notice and wonder. I see a lot of us already getting started on this. So I'm gonna give us all about a minute. So what do you notice and wonder? Again, let me also make a comment here. A, B, C, C, D are called the parameters. And our parameters actually can transform a parent function. These are the things that you can like stretch, compress, so forth. So these are called the parameters. So we can transform a function, a wave function, or we can create a function. So yeah, just so that y'all know what I mean when I say parameters. Anyways, let me give y'all a minute. We are on column 9. I'll go ahead and put the directions once more in the chat. Let's see us back in a minute. All right. I hope y'all had enough time to go ahead and write your post there for our notice and wonder. So these are great notice and wonderings. I was just taking a look. So that's awesome. So you're digging into what this might represent. A lot of you were noticing that like it was helpful. The color coding kind of shows you what it kind of means, but then some of us still had some questions. um like, I wonder what is amplitude, or I wonder what the D means. How do we find a vertical shift? So there's many questions which are very legit, and we're going to get to touch on those. um and then here's an awesome wondering. I wonder if this is something that can be used in physics. Definitely, actually. So physics, they study, I think they have a whole unit on waves. So definitely. So yeah, today we're gonna get to answer some of the questions that you have. Perhaps not all of them, but definitely some of them. We're gonna touch on what is vertical shift, how do you find amplitude, all of that. All right, y'all. Do make sure that you put your name or initial there and put your post. Let me know if anyone's having trouble, or for some reason you're unable to post. Let me know. But other than that, let's go ahead and transition us back into our slide. So that was part one of our participation. Now let's go ahead and talk about what are the parent functions here for this unit, or for the main parent functions right here. And I am on slide number 7. So we've seen this before. So this right here is our sine function. Um, the sine function basically is like an up and down curve. And this sine function repeats every 2 pi radians, and that's equivalent to every 360 degrees. So here's, like, for example, from 0 to 360, this same wave is going to repeat. Or you could think of this as from 0 or 2 pi. So every 2 pi radians, this wave repeats. So one thing you should definitely pay attention to is that our sine function starts at 0 right here, heads up, to the value of 1. This is 1 here. So this is like 0.5 or something. So it heads up to 1 at pi over 2, and then it goes back down, and it goes back down to -1 down here. Then lastly, your sine function goes up and goes back to its starting position at 0 right here. So this is one period of a sine function, and this repeats every 2 pi. This is the parent function. Like, this is the one we're going to look at. And if we want to transform this or change it, this is the parent function we'll be using as a guide. So there's your parent function for sine. So that's sine. Here are its properties. Let's take a look at the parent function for cosine. So take a look at what's similar and different here. And I know we actually already looked at this before. But cosine is just like sine, except it actually starts at 1 instead of 0. See how it starts at the value of 1 up here? It starts at 1 instead of starting at 0 like sine does. And then this one heads down until it hits pi radians right here. It also hits it at -1 in the y value right here. And then it goes back up again. And this one completes one round of its cycle, also every 2 pi. And this is one cycle right here. And then this just repeats every 2 pi as well. So both of these have a period of 2 pi. And these are the parent functions. We're going to be using this today to help us. Let's see if anyone has questions about the parent functions here. All right, cool. Let me go ahead and clear my screen, and let's move on. So that's our parent functions. They're going to come back. You'll see. Oh, yes. Don't forget about tangent. So unfortunately, in the module, there's not enough time to deeply investigate tangent. But this is how tangent function looks like if you're to graph it. It has these dashed blue lines. These dashed blue lines are actually not part of the graph, but they do represent an asymptotes. They represent asymptotes, not an asymptotes. So it has, as you can see, tangent has a completely different shape, right? It goes between negative and positive infinity. So forever, it repeats the same kind of like, I don't know how you would call it, same curve thing. Um, and then as you can see down here, it says that it crosses through 0 at every pi radian. So what it means by that is this right here. It crosses through the x-axis. We call that crossing through 0 at every pi radians. Tangent is indeed a periodic function, because remember, periodic means you're getting like a repetition of those y values over a certain domain. And in this case, the domain is every pi. So the length of the one interval, or the period for tangent, would be pi. So that one's interesting. Again, we didn't really get to investigate how this comes about, but it's very definitely good for you to know, because you could still transform and take a look at tangent functions as well. Like just having the parent graph alone can help you do that. So let's see if anyone has questions about our parent function for tangent. Okay, awesome. I was just looking like on my YouTube. I think a bot made a comment. I hate when that happens. All right, let me go ahead and clear this up. All right, that was our parent functions. Now we're going to talk about one more thing before we jump into some examples. So the definitions. So here what I have for you are different kind of examples of some, either a sine or a cosine wave. I don't know, whatever it is. If it helps, you can think of it as a sine wave, but like different ways we can apply what we saw. So for example, in this wave right here, the period length is 2 pi. And this wave right here, the period length is a little bit shorter. It's pi over 2. Phase shift is when it shifts side to side. Amplitude is when you measure from the midline to a peak. See how that amplitude right here would be 2. Vertical shift is how far up or down the midline moves. So don't worry, I'm going to talk a little bit more about that. That's just a general overview, but here are the definitions. I'm on slide 9. Number 1, the period. We talked about this yesterday and we kind of did some more practice on it. That is the length of one cycle, and the period repeats itself. So the cycle repeats itself for every period. Amplitude is the distance from midline to a peak. So midline, that's also probably a new word you probably want to make sure you write down. So midline is basically when you draw a horizontal line right through the middle of your curve, like this. So it's kind of cutting it directly in half. So amplitude is the distance from midline to a peak. So from here to here, the distance, even though it's hard to see in the graph, is 2. So from the midline to the peak, that distance would be 2. That is how we get amplitude. And some of you asked this question on the Padlet. This one, the amplitude is 1. The midline for this one is actually right on the x-axis. So let me draw that midline. It's right in the middle, right here. And you count from the midline up to how high it goes. This one only went up 1 unit. See, the 1 is right here. So our amplitude is just 1. That is how you find amplitude if you're given a graph. Phase shift. Phase shift is basically any horizontal shift either from to the left or to the right. So in this example right here to the left, there is no phase shift. It says phase shift is equal to 0. The phase shift is equal to 0 because if y'all remember the parent function for sine, so this looks like this is a sine wave. The parent function for sine started at 0. Because it still starts at 0, this wave, the phase shift is 0. So this one had none. Whereas this one does have a phase shift. It has a phase shift of about 0.05. So that part, that initial point got moved over by 0.05 units. So no phase shift versus a slight phase shift. So again, phase shift is a horizontal shift from the left or right from its usual position. So usual position is when we look back at the parent graphs, parent functions. Now vertical shift is how far the function is shifted vertical from its usual position. So for both cosine and sine, the waves are usually centered on the x-axis. If they're not centered there, that means your midline is not on the x-axis. What you have is a vertical shift. So this line, this midline right here, naturally should be down here. Naturally down here. That would be where the midline would be at. But the midline appears to have been shifted, and this looks to be, I think this should be 3, because this is 2, 3, and then 4. So the midline looks like it got shifted up 3 units. So for this one, we'd have a oh yeah, there we go. Yeah, vertical shift of 3 right here. Whereas if you look to your left, this curve is centered right on the x-axis, so there is no vertical shift. And I think lastly, no, that's it. Okay, sorry, let me go back. Now let me pause to see if there are questions. So here we have verbal written out definitions, and then we have the visual that I kind of walked this through. But if anyone needs me to re-explain any of these definitions, feel free to let me know either privately or openly in the chat. Let me have like some processing time for y'all to take a look at this. Okay, that's awesome. The color coordination is really helpful. That's great. Yeah, definitely. You have this slide to always go back to help you out with that. For sure. I love the color coding too. I try to when we have the time. When it was in class, I would try to use different markers, but then that would take forever. But yeah, I love color coding. Okay, let me go ahead and delete that. Unless there's any burning questions, I'm gonna go ahead and take us to the next slide. Slide number 10. Now, is that the examples already? No, no, no. Slide number 10 is the formulas. So, oh, sorry, let me pop this up. There we go. So first, I'm going to talk about these. So there are formulas to know, right? So if you have the parent function looks like this, it's a sine bx plus c. Oh, there's a typo. 1 second. Plus d. There we go. That'll be weird. Okay, here are the formulas to know. Amplitude is the absolute value of A. Absolute value, y'all, basically makes whatever number positive. So if you have the absolute value of 2, your answer is 2. Absolute value of -2, the answer is going to be 2. It just makes whatever is inside of it positive. So make sure to make a note of that in case you feel like you're going to forget that on your slide. Definitely. And then another formula, and it's funny, y'all. This formula came up in my last period. So I'm like wondering if y'all seen this before. If not, that's okay. But this came up. But how to find the period if you're looking at an equation is going to be 2 pi over the absolute value of the b term. See, here's b. It probably helped if I had color code this one. So this should be like blue. How you find the phase shift if you have an equation is you just put C over B, and that's going to tell you how far to the left or to the right that your function has shifted. Lastly, the vertical shift, the D term right here, that's the thing that tells you how far up the midline moved or how far down the midline moved. Lastly, frequency is going to come up in your mini final. The frequency is basically 1 divided by your period. You'll see like if something has high frequency, you'll see it having like many little waves. Low frequency, it's pretty stretched out. So this is for sine and cosine. As you can see on this right-hand side, this is if you're interested about tangents transformations or some formulas for its transformations. As you can see, tangent doesn't have any amplitude. If you also go back a few slides, remember tangent didn't look like a wave. It looked like a weird long repeating curve, kind of every pi unit. So that's why it doesn't have any amplitude. And if y'all remember, the period length for tangent was just pi. So that's where this comes from. Otherwise, the rest of the formulas for tangent are the same for sine and cosine. Again, our focus though, we're going to be focusing on like sine and cosine waves, not so much tangent, but this is just if you're interested to know a little bit more information about tangent. So let's see if anyone's questions or anything about these formulas. Cool. And I put a little note again about the absolute value there in the chat. Don't be afraid of it. It just makes whatever is inside of it positive. Is that what I said? Yeah. Okay, great. I thought I wrote negative. Okay, awesome. I'm going to go ahead and transition us into slide 11, y'all. I think it's time, yeah, for applications. I did color code this though, so you can follow along which part. So I am trying to create an equation for this, and we know it's a sine function. By the way, if you have a wave and you don't know if it's sine or cosine, it could be either because cosine is just a shifted version of sine. So there could be multiple ways you could create it. But for this one, let's just say it's sine. Okay, we're looking for A, amplitude, B and C, and then D, which is the vertical shift. B and C have a little bit more complicated definitions. As you know, B kind of tells us more about the period. C over B tells us if we have a phase shift or not. Okay, so here we have a graph. We're going to come up with an equation. The first thing that I'm going to do is I'm going to plot my midline. Remember, y'all, my midline is the line that cuts my graph horizontally in half. Wow, y'all, I thought this was my straight tool. I did pretty good. So this is the first thing I did is I drew my midline. I'm going to type that. That's the first thing. And that way I could easily kind of figure out what my A would be. So amplitude, if you go back to the definitions, it is the distance from the midline to a peak or to a maximum. So because this is 1 and this is 2, the distance from 1 to 2 is just 1. So therefore, my amplitude is going to be 1, which I wrote up here. By the way, these popped up right here. I forgot to mention. So if I was in class or if you're at home, right, the things you would want to look at when you're creating equations for a sine or cosine function would be the parent graph. So what I pulled up was the parent function. I showed you all this, I think, in the third slide today, about the third slide. So this is the parent function for a sine. And basically, I'm just comparing it to the parent function to see what is changing and what's not. The other thing you would have like next to you, like on a paper or on like on a tab, would be your formulas, because we're going to be jumping to these formulas as we do this. So right now we've got that the amplitude is 1. The absolute value of 1 is just 1. So that's why I don't really like mind or didn't really pay attention to that amplitude absolute value portion anyways. We just get that it's 1, the distance from midline to a peak or midline to a maximum. Does anyone have any questions on how I got the A equals 1? Amplitude is 1. Okay, cool. So that looks fine. Let me clear this. Okay, next, let's try to figure out maybe what b is. And how I could figure out what my b term is I'm going to be using this blue formula right here, 2 pi over absolute value of b. Um, but one thing I want to check before I do that is I'm going to check, well, actually, what is the period of this function? So what is the period of this function? First, let me figure that out because I don't want to use this formula and do extra work. If the period is the same as the parent function, that means I don't have to do that extra work. Let me show you. And I'm going to also change my color to blue so that y'all know I'm doing the blue part. First, let's check the period. So remember, y'all, as a reminder, how you check the period is you find the distance between two maximum. So the distance between these two is 1, 2, 3, 4 squares. So I don't know what 4 squares represents though. So again, I'm going to be using my x-axis as a ruler and I'm going to count 4 squares to see where do I end up at. 1, 2, 3, and my last square 4. The period is 2 pi for this function. That means its cycle repeats every 2 pi. But guess what, everyone? The period for my sine function was, the parent function for sine was also 2 pi. The length of that is also 2 pi. So because this period is the same as my parent function, we don't have to use this formula to do extra work. We therefore can just say that because the period is the same as the parent's function, we say that b is equal to 1. So there's not going to be there's going to just be like a 1x in front. So you're going to see that in a second. So again, you can, if you want to, try to use this formula, but you're going to see that you're going to get a b value of 1. So I prevented us from doing extra work by checking, like, wait a sec, what is my period here? Oh, it's 2 pi. That's the same as the parent. So we're going to say that b is equal to 1. So let's see if there's questions about that part and on how I got b equals 1. In the next, by the way, in the next example, you'll see an example of when I do have to use that formula down here. So stay tuned for that. But look, we're halfway done, y'all. We have a is 1, b is also 1. Let's figure out what c is. So c deals with a phase shift. So phase shift means any horizontal movement of the parent function. So side to side movement is horizontal. Well, before you do any extra work, check your parent function. So remember, the parent function for sine started right here. Horizontally, it starts, so what I mean by horizontally, so for example, right, the horizontal value is going to be my x value. So x, y. So horizontally, this starts at an x value of 0. And this one here, the coordinate point is going to be different, right? It's going to be 0, 1. But horizontally, it stayed the same. The x value is still 0. So y'all see that? So this did not move. It did move up. We'll say that it moved up, but did it move side to side? It did not move any side to side. It did move up, but side to side, it stayed in the same position. Let me check the chat. Hold on a sec. Okay, sorry. That was just a personal question. I thought there was a question. So once again, the phase shift here is just going to be 0. There is no phase shift because my first off, the starting point x value did not change. Again, you can go through and try to do some extra work here and figure that out, but the sine function did not shift at all horizontally. So we're going to be saying that C is equal to 0. So there's no shift. So C is equal to 0. Lastly, okay, good. We got A, B, C. Now we just need D. D is your vertical shift. And I usually like these because vertical shift I think is nice. So in order to find the vertical shift, what helps is to first draw your midline, which I had. I just erased it after I found the amplitude, but here it is once again, my midline. And my midline is located at the y value of 1. So instead of being down here like the parent function has it, see parent function, it was centered right here on the x-axis. Because this actually got moved up by 1 unit, so it moved up plus 1, we're going to say my D is going to be equal to 1. Got moved up by, shifted up 1 unit. So here we go, y'all. We have amplitude is 1. My B is 1 because the period was the same as my parent function. There was no horizontal shifting, so we got C right here is 0. And then your D is basically your vertical shift. This indeed, the purple graph right here got shifted up 1 unit. You can compare it to the parent function. So let's put this all together. So I'm going to go ahead and take this and start to plug in all the findings that I just had. And there you go, see that? So I plugged in 1 for amplitude, plugged in 1 for B, plugged in 0 for C, and my 1 for D got shifted up 1 unit. Now, this is correct. This wouldn't be wrong if you wrote this, but you can simplify this to this. And remember, 1 in front, basically you don't need to write the little 1 in front. So that's why it just becomes sine x plus 1. That is the equation for this purple graph right here. So let me pause to see if there's questions about what I just did. And let me mention again, I didn't really have to use these. I didn't have to use the period formula, nor did I have to use phase shift. You could save your time. You could save yourself some work if you compare this to your parent function. Or you could do the extra work to kind of verify stuff. One thing we haven't done yet, but it will come up later in our mini final, is frequency. But for the moment, let's just pay attention to the ones that we are talking about. Oh, wow, everyone. I guess we're not, it looks like we need to actually jump into the Google form. It looks like we won't be able to actually talk about example 2, but I definitely want you all to do the Google form so then we could kind of talk about that one. So I could kind of address things. So I did only go over one example, right? But, all right, let me just clear this up if there's no questions or if anyone has burning questions. There's only one question on the Google form, y'all. But the next example, right? Same thing, same process. But in this example, I do talk about using the period formula to find the B term. So y'all can just check that out and see how that works. I did try to kind of like annotate my steps to get that B term. But then the rest of the process is the same. This one does not shift. And my D is going to be 3 here. So y'all can check out this example. But for the moment, let's just do the Google form based on what you saw in example 1. And if you want to, you could check out example 2. But this is here for you. It's color-coded step by step for you to kind of make connections there. So let's jump into the Google form, everyone. And that's to just kind of check, what do we so far have? What do we so far understand? And it is one question, everyone. So it should be a short one. And we'll see what y'all think or what we need to work on a little bit more. I went ahead and I stuck this into the chat. If you are with me on the slides, it is slide number 13. Let me open it so we can look at it together. Take a look. It's only one problem. I'd like you to attempt to create an equation for this sine function. So try your best using what we discussed in example 1. You could also feel free to look at example 2, even though we didn't get to talk about it. All right, cool. Let's go ahead and take the next, looks like we're gonna have the next 7-ish minutes to do this Google form. Let me know if anyone has any questions. I'll be right here. Let me actually enter in a timer. By the way, y'all, try your best to type out the answer. And if you could, let us know like what you tried or how you figured it out. That would be great because then I get more information about where we're at and what we're doing. That would be awesome. But yeah. Okay. Let me start this out. See y'all soon. All right, everyone. So I see a few of you are done. If you are not done, please make sure you get this in by evening. This one I'll take a look, start entering stuff. So we're definitely going to open up our next class and talk about how to actually create the equation for this. So stay tuned for that. But otherwise, give it your best shot if you're still working on this. Oops, there's our timer. Sorry about that. All right, everyone. Because we're at the end of class, I'm going to go ahead and close this meeting. But again, make sure that you complete this so I get some information, you get some information. My office hours are today. But right now, I'm going to have to close this meeting, but then I'll open it. So if you're interested, come by, stop by. Y'all have a great day. Bye, everyone. I'll miss you guys. I won't see you tomorrow, but bye. Bye, everyone. See ya.